G'day, this is Wally11 from the future here. I took a bunch of video on making a parts box, like a bibs and bobs compartmented box for holding your bibs and bobs when you're doing stuff. Now what brought it on was I had a shipment come in of blade fuses, and they came in little plastic bags. I was expecting to get a nice little, clippy box that I could clip and put my fuses in. But they came in plastic bags, and by the time I got the plastic bag open and it ripped and blade fuses went in all directions, I was like, why don't I make a 3D printed box that I can put these in? So this is Neil from the future, and the reason I'm Neil from the future is because, guess what? My microphone stopped working as a recording device on all of my videos. So I took quite a few YouTube videos and did all this stuff, and there was no sound on any of it. There was not just this video, but there were a couple of other things that I'd recorded intending to put them up to YouTube. And of course, when I came to do all my editing, there was no sound. Eee, check it out. This one's a 45-cent cup of coffee. They were $4.50 this week. Oh, it's nice and warm. I'm just doing a bit of editing up at the moment, and I tell you what, I'm looking about and seeing what's going on. There's a lot of noise going on around me. There's construction. There's someone playing music. So if you can hear all that in the background, I apologise, nothing I can do about it. I'm just going to plough on regardless. I've got an itchy ear, so if I start scratching my ear, please excuse me. Right, and I've got people wanting me here. Yes, I know about that. Thanks for reminding me. Now, where did I get up to? I was talking about this project box. So I thought we're going to be using OpenSCAD, and we're going to be using Repetia Host. And the reason we're doing this is because, why is that open? That should not be open. I don't know what's going on. I know nothing. The reason we're doing this with OpenSCAD is we're going to get an opportunity to do a little bit of advanced programming with it. And when I say advanced, this is really basic advanced. All right? I'm not going to do a deep dive into OpenSCAD. There's plenty of people that have done that. And if you're looking for something more advanced than something that's bite-sized, please by all means go and look on the OpenSCAD forums and deep dive into those, because there's plenty of people that have put up lots of stuff. Now, once again, I do this based on my experience. So anything I do and say on these videos, there's no liability attached. If you do something and you get hurt or whatever, you're doing so at your own risk. So you're following along at your own risk. And if you can't accept that, then by all means click this off and off you go. This is just my attempt to give back to YouTube. Righto, so let's get on with it. What we're going to do, because I'm Neil from the future, is we're going to make this. And this is a hinged project box with blade fuses compartments in it. Whee! And they're falling out of it. But the beauty of this is, and the fuses are still in their compartments. Ha! You thought they were going to be all mixed up. No, it's a good fit. The lid fits beautiful on the box. It's got these little curved sides on it so that you can, I don't know why that's crooked either. It shouldn't be that crooked. But it's got curved edges so you can get your finger in there and scoop the bit out. Now this looks crooked because this lid didn't print. See how it kind of went cattywampus on the corner on me. So I didn't quite get the result I was looking for in terms of a nice clean print. but it's doing the job, and that's okay for me. I can stick a few of these in and stick them one on top of the other and put labels on the front. And, you know, they're hinged. They got a hinge on them, and that hinge will stay up there. You can do your thing, put it away, put it back in a stack, and they can stack up on top of your power supply. You can stack them one on top of the other, side by side, whatever you want to do. And I think that's a brilliant idea. So that's what we're making. And I'm going to take you through this step by step. I'm going to take you through using the extrude function. So we're going to be working with linear extrude without twisting it. So because it's just a shape that we're going to push and turn into a solid, and then we're going to excavate that with another shape, which is the thickness of the wall indented, you know, and positioned, and then it bores it out, and then we're going to put our dividers in, starting at the front and spacing all the way along till we hit the back wall. So that's what we're going to attempt to do, and we're going to get a slightly odd compartment at the back. We've got a little hinge in there, so it's going to be a little bit bigger, and I don't mind that. We're not adjusting for the thickness of the dividers anywhere. So the last compartment's going to be a little bit thicker than the others, and I don't mind that. I'm happy with that. So yeah, strap in, let's get into it. Righto, have you ever had one of those feelings where you're talking to to yourself? Well, that's what I've been doing for the last 5 minutes, not recording. Okay, now that I'm recording, here's our written plan of what we're going to do. Always start with a written plan. It helps to avoid feature creep. It gives you your dimensions. You've got some idea of what you're doing. You got a lid. The lid has a lip on it. So you've got some kind of a lip on the lid. You've got a height, you've got a width, and you've got a length. So you got enough bits and bobs there that, you've got enough stuff to get you going. I'm going to put this curve in it, so I need some kind of a radius, which I've decided is going to be 10 mil, the difference between that and that. So if we change the width, this radius will stay the same, but we'll vary the width. So I've just come up with some dimensions. I've come up with an idea of what I want to build, how many compartments. I've got compartments, so I need a number of compartments that I'm going to put in the box. I don't know how many that is yet. I'll probably end up with a 10 compartment box with five aside. So yeah, you can make it 4 aside or 3 aside depending on what you're doing. You might only need 6 compartments in your box. You might want to make it a bit shorter. You might want to make it a bit longer. That's up to you. You can make it whatever you want. But that's the plan, and we're sticking to the plan. And because we're sticking to a plan, we're not going to be spending hours and hours and hours making this thing. Now what we're going to do is make this basic shape here. See this? So this is basically 2 circles, one there, 2 circles, a rectangle there to join the circles at the bottom, and a rectangle there to join the circles at the top, and fill in the bits that we want filled in. And then we're going to extrude that all the way to the back. And then we're going to build another one, the same shape but slightly thinner, and we're going to use that to scoop out the middle, and that's going to be our chassis. Our lid's just going to be a cube inside a cube, or a rectangular box inside a rectangular box. Nothing special about the lid other than it's going to have a little hinge bit at the back, and we've got to decide how we're going to build the hinge. And that's really it. That's what we're going to be building, so it shouldn't take us very long. Let's get into it. Just filing that away in my folder of plans. I've already built this thing, so here's one I prepared earlier. I'll show you what it looks like. Alright, so that's what it looks like on your printer. Now I had a couple of challenges with this. One challenge I had was getting it to fit on the bed, because I initially had this at 10 centimeters by 10 centimeters. Of course, that's 20 centimeters, and that's basically the width of my printer bed. So I had to drop this down to 80 mil by 80 mil, which gave me 16 by 15. These are 15 long, so it's 16 by 15 with a little gap in the middle there, so it would fit on the bed of my printer. That's the first time I've actually used the full bed of my printer, so I got a little bit of a problem with the lid. I figured out I've got a bit of a calibration issue on one corner of that printer, and what that meant was it actually lifted up off the bed. It didn't stick to the bed, and because it lifted up, it bent one of the lid corners. But the printer just compensates for that because it pushes the head through and melts the plastic, and it just keeps the rest of it level. So because we were at 2 mil thick, it really didn't worry me. Didn't worry me at all. Now let's talk about what we're doing. We've got some stuff at the top here. I always put the name of the file and the date and who did it, right? And I'm going to release this code. There's going to be a Git repository. So there'll be a Git for it, and you'll be able to download this file and my STL file that I've used to do my 3D printing. Now you can change these dimensions, and I've already changed this because that is actually 80. And I've put a 10 compartment project box with a hinged lid. Save it. Now the one thing I didn't do was I didn't put holes in this lid. I should have put a couple of little holes, and I have to still drill those holes out. I haven't drilled anything. So what I should have done was put a couple of holes in there so that hinge doesn't move on those pins. Right, so you can see I've built these little hinges here. They're strengthened with a little cube in there. This compartment's a little bit bigger than the others, right, just a little bit, and that's to allow for that. So we didn't adjust for the width of these in our placement of those dividers. We did not allow for the width of the dividers or the end, the widths. We didn't adjust. So we ended up with our last compartment being a bit wider, and I'm fine with that. I'm absolutely fine with it. So you can see how it's going to work. This is just a cube hollowed out with another cube, and what I'll do is I'll show you how that works. Actually, I'll show you real quick. I'm just going to comment out the box itself. I'm going to comment that out, and I'm just going to build a cube. Where are we? Where's our lid? Right, so this will work. I'm just going to show you how this works. In fact, I want that bit of code, but I'm just going to do it with cubes. So all it is we built a cube, which isn't really a cube. In this, cube doesn't mean cube. It means quadrilateral. It's a polygon. That's what it is. It's not actually a cube because they're not equal distances. But you can use cube, that's what they've called it, to build a box. And all this is going to be is a cube width. If all you want to do is build yourself length, height, right? And we'll have another cube. Which we've got to translate. T, comma, T, comma, T. Right, and it's got to be minus T times 2 because you've got two sides. So you've got to bring it in 2 times the thickness. So you want that on the width and the length. And you can leave the height because it's got to penetrate the top. So let's just run that. What did I do wrong there? I've got this problem here. Right, and I'll just show you real quick what we've done there. And all we've done is we've used one box to scoop out the insides of the other box. Righto? So there we go. That's what we did. What I've done is highlight the box that's scooping out the other box, alright? I just want you to see all I've done is I've come in the thickness, right? And I've used that box to scoop out the other box. And if I take the highlighting off, you'll see we've got an empty box. There you go. And that's how this works. You use difference and union is the other one you can use. I don't use union a lot. I tend to group my things in modules. So I don't have to use union. I do have to use difference. I don't need to use union. But when you expressly want things to be together, you should use them inside a union command, and it knows to put them together. So to join things together, you can use union, and to split things apart, you use difference. Now let me recommend that you donate to these people. So in their about, you'll find a donate button. You can download from their You can download from their website, openscad.org is their site. And you can see they give you a bunch of libraries in here that you can go play with. And there's lots of advanced stuff in there. There's a bunch of people contributing. There's a bunch of, maintenance admins. Bunch of patches, translations from different languages, blah, 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 etc., etc., etc. And as you can see, it's a pretty well contributed to bit of kit, and it's a good bit of software, and therefore you should donate to it. If you're using it, you should be donating to them because they rely on those donations to keep going. So there you go, there's a box. And we're building that. That's exactly what we're doing for the lid, except that we are chopping out one end of it. So to build our lid, all we did was we said in the length direction, don't take out that. In other words, chop it out. So chopping out one end of it gives us a lid. There you go, one lid. Only, of course, we only got to come up the height of the cube is the lid lip. Not I. Not I, you dopey. The lid lip. And that's how we built the lid. There it is. Now, we do things a bit differently because I subscribe to object-oriented design. I'm going to delete all that. And we're going to do these one thing at a time. So the first thing we're going to do is we're going to show you the outer base. We're going to build this first. Okay? Right? Ooh. Right? Right, so there's our base shape. Now the first thing you'll notice is that it's in the wrong plane. It's in the XY plane. And if we do this in stages, outer base, here we go. I'm just going to show you that we've got two circles spaced out to the width. So you see we've got two circles, and then we've just added two rectangles. We've got a rectangle in here, and we've got a rectangle in there. Right, so that's what we've got, two circles, and well, they're called squares, but they're actually rectangles. Now, the only thing with the circles is we had to space them the width minus the chamfer height, right? Minus the chamfer. The chamfer radius was 10 mil. So that's 10 mil radius on that. And that CH we've got in the properties up the top is our chamfer radius. Right, so that's where we declared it there. We could change that to 12, right, and we get a bigger circle straight away, and we wouldn't have to change anything else because we've done this as an object. Right, so we could change it to 30. Let's change it to something ridiculous. 30. Really big radius, right? Whoa! Now suddenly things don't work because our minuses don't work. Obviously, we've gone beyond the height of the thing, so that's going to, when we do a minus 30, it's going to become a 0. So it's not going to have any substance. But we could go, I don't know, 20. I think we could do 20. Yes, and we're going to get funny results at some point because we haven't got enough height and width, and we've got to change things around. But we said 10 anyway, so let's leave it at 10. And we could do these as percentages of this. So we could change these to calculations based on this chamfer radius, and we'd still get away with it. Rightio then. So what are we doing next? Okay, what are we doing next? We are doing the extrude. We've got our base shape. We're going to do an extrude on this base shape to give us a solid object. Remember, we built our rectangle, which is just a solid block, and we've called this our chassis. So in chassis, here it is. We're taking our outer base shape that we've just built here, and we're extruding it the length, right? The length of our box, which is our height. So we expect this to go up in the air. So let's put our chassis in. We've explained how we built this base shape. This is just a two-dimensional shape, which is the starting point of every extrude. It's a two-dimensional shape. We could have used a polygon and designed this with polygon. And we wouldn't have got that, like if we changed one of the factors in the polygon, we would have automatically scaled that out in the polygon and we wouldn't have got those other results. But this has limitations, as you saw, but generally if you keep it sensible, if I drop that down to 4, I'd have a little circle in there, and this would still work. If I drop it down to say 4, let me just show you that I can. Like I can drop it to 5. Let's drop it to 5. Let's halve that, and you can see I've still got my rounded shape and I've still got my edges. So, 10's a good number and it's a good shape. It works pretty well. So I'm happy with that, and now I want to do a linear extrude on our chassis. Well, let's get that and run the chassis. So what we expect to have happen is we expect that to shoot up in the air. So let's run it, and there it goes, up in the air. And that's the full length. It's a solid object, right? There's no gaps in it. And there's our two circles on the bottom. And that's now done. Now, what would happen if we just scoop this out so it becomes a big U-shaped object, right? A huge U-shaped object, but we don't want it to scoop out the thickness at the start. So we want to leave this bit in the same way we did for the lid. We just want it to go and scoop that out, leaving our thick wall here. Good question. Good question. So we've now got our inner base. And I'm going to take these circles out of here. And I'm going to add to our chassis I'm just going to overlay this inner base. I'm going really well this morning, okay? Really well. And I'm going to highlight that so that you see it. Well, let's run that. And that's exactly what I want you to see. And you'll see that there's a 2mm lip around, because we said our thickness was 2mm. So you can see our inner base, it penetrates the top. Right, it penetrates the top. Try to show you properly. You can see it penetrates the top and leaves us with a 2mm lip. And it runs the length of the whole build minus the thickness of the final lip. So what we did to make that happen, if we look at our code, is we've got this inner base and we're translating our circle again. Okay, so we've got to place our circles where we want them. I'm not really sure where I did the translate. I'm not really sure why it's there, because I didn't think I did that yet. Anyway, our dividers, of course, I've confused the crap out of myself here. Here's our box void here. We've got a linear extrude height. And you can see I've translated it to thickness, so I've moved it in the Z direction T. I've got chassis there. Okay, so I've deducted T from the height. So when I do our box void, I actually translate it by T and then I move it in minus T. In the Z direction. So I'm absolutely leaving it with a okay. I'm not really sure how I've got this done, but when I do the box void, it hollows out my box. I confused the crap out of myself now. I've probably confused the crap out of a bunch of you guys. But you can see there's my box void. And I've stopped it short of the end by T. See that? So we've got our thickness at the end. So that gives me my curved shape with my 2mm thick wall. And what I do is I reinforce this anyway when I do my divider. So my divider is the outer base, but the height is only the thickness. So here's our divider that goes down the middle. So let's build the box. So I'll take you through the box, and you can see I'm doing the difference between this chassis and box void, so that gives me that hollowed out box. Right, so that's that bit there, that's what we did. And then I'm doing a for loop, and I'm asking it for this C. Now I did that up here. Compartments per side is C, and I've said 5. If I only wanted 4, it's giving me 8 total compartments. I would have done 4. That would have given me 8 compartments. Because what I'm doing is I've got my center divider here. Right? So that's the center divider. And that puts the one right down the middle. And this one here, it basically takes this divider that we've declared down the bottom here, which is the same outer base with a height of 2, with the height of our thickness. And I'm starting at 0, so I'm rebuilding this hollowed out bit that we've got it right. That's at the same point. It doesn't really know how to render that because it's at the same point. So you might end up with a bit of funny film there. If you built this, you'd end up with a bit of funny film. So what we've done is we've said, nah, I want that rebuilt. So we start at 0 and we go down for the count -1. Right? So for 0 to C -1, which gives us 4 dividers to give us 5 compartments. And that'll work. So we translate times the DG, and DG is a calculated variable here, the divider gap. It's the length divided by the number of compartments. The lid overhang, we've got this tolerance of 0.1, right? 0.1 of a millimetre. No, we've got this 10% of whatever the, I've said 2.1. Okay, I meant that to be 1 millimetre, and as it turns out it is, because we've got a 10 millimetre, so 0.1 of 10 is going to be 1 millimetre tolerance. So we've got a 1 millimetre tolerance, which works just fine. And the add-on, I've 2 times the thickness. So I've got the OH, which is this tolerance, plus the thickness times 2. So, yeah, the overhang is actually getting out there. It overhangs by quite a bit. All right. So let's not confuse the crap out of ourselves. Let's just keep going. What we want to do is print the box itself. Now, what I'm doing with this is I'm translating it, because you've got to remember this is in the Z direction, right? So currently our box, if we just do box, you're going to get our dividers with all of our hinges and clasp, but it's in the Z direction and we want it in the XY plane. So we need to do a translate to move it, and then we need to rotate it 90 degrees. So if we just did a rotate, it would be in the negative XY plane. We want it in the positive XY plane. So we're moving it its full length in the Y direction, and we're rotating it 90 degrees around the X axis so that we get it back where we want it so we can print it. And then we're translating 1.07 times the width and printing out the lid. So this is how we print the box. And we're done. So let's just print the whole box. We haven't really changed anything. All we've done is add the lid. I've shown you how we built the lid. There it is. Now the one thing we can do is we can add a hole for these in this lid. We can do that. And when you look at this, I'll see if I can get it to line up so that you can see it. Right, you can see this ends at 150 and this is going close to 160. But if we put this at length, so if we chuck this hole in there, we actually get our overhang. And we really do want it sort of nicely in the clasp. So what I'm going to do, so that I get an accurate feel for where I want it, right, I've got my box that I've built and I can see where I want it to be. And I'm going to cheat. I'm going to figure it out using my calipers, because that's the ideal spot to put it. It's 5 mil. If I come back 5 mil from the end of that and drill a hole through it, I've only got to make that hole the width of the hinge, and life's good. So that's a 5 mil. 5 mil. It's actually a bit more than 5 mil. Doesn't look like 5 mil to me. Where did I measure to? I measured to the edge. I didn't measure to the edge of the hinge. Duh. Fool. That's closer to 6. Let's go to the center of the thing. That's a 7 mil. That's a 7 mil gap from the end. I'm happier with that. Much happier. We'll call it 7 mil. I'm going to call it 7 mil. So I'm going to come back here 7 mil and down halfway through that lid and put a little hole through that, right the way through that lid. Let's do it. So we're going to say in lid void, let's just do lid. Let's just look at where that lies. We're going to add this. This is a bit of feature creep. It's not really, because I wanted to do this anyway. And you guys will probably want it anyway. I'm going to just comment the box out for a sec. Right. And we said it was going to be 7 mil. So it's going to be 7. I'm pretty sure that's going to be close to that overhang. The lid add-on. That's 7 mil. It'll be very close to this number here. Let's have a look at it. I'm pretty sure we're going to find it's close to this OL. Let's just echo out OL. Let's see what that number is. 8.2. So it's OL minus 1. I think I'm happy with that. I think I'll come back OL minus 1. That way, if we change dimensions and stuff, that should pretty much go close to where you want it. So we're going to say OL minus 1. Right, so we want to translate OL minus 1, but we need to go out the length of the lid. Alright, so what we need to do is we need to come out here, this length, minus OL minus 1. And then we're going to put a cylinder all the way through that at the height we want it, which is halfway, you know, so it's going to be the lid lip over 2, LL over 2. So let's work out the translate first. So we want to translate I keep things together. We want to translate the lid minus OL. This is in the Y direction. In the X direction, we want to go minus 1. So in the X direction, we want to come back. We want to come back minus 1. So we get penetration. So we're saying minus 1 in the X direction. Our length is length because we want to come back minus OL minus 1. So we want to knock that out. So it's L minus 1. And in the Z direction, we want to go up LL over 2. And we want a cylinder. LL plus the diameter of the cylinder plus T. We want it in the middle. Our diameter is T. We definitely need to do the same rotation as the hinge. So we want to do this rotation. We want it in the same direction as our hinge. And our width is going to be W plus T times 2. It's going to be width plus, what's the width of our cube? In our lid, what's the width of our cube? L plus OL. So our height is going to be that, plus 1, plus 2. L plus OL plus 2. It's got to be the width of the lead and penetration, and we're going to put 2 mil on it to make sure we penetrate. Everything else there should work. Oh, crap. Put it in the right spot. So that's our hinge hole, and that needs to go into the lid. So we just need to add that to our lid void. Here's our lid void. Add that, and we should be good. We should have a hole through our hinge. Ugh, what didn't it like? Translate, rotate, blah, blah, blah. Where is it? 137. Where's 137? What did I do wrong there? 135. I didn't close it. Right. Let's have a crack at that. And we should have a hole somewhere. Where's our cylinder? Oh, okay. We chucked the hole somewhere, but we don't know where. Where's our hinge hole? Let's figure out where it went. We can't be too far out, surely. Where's our hinge hole? Whoa, we went the wrong way. So, why is it going that way? We did a rotate minus 90. Let's just rotate 90. No, Control Z that. We rotated the wrong thing. Hinge hole. Yeah, we did that. We don't want that. We want that. Okay, we're definitely getting a hole through things. We're miles too long. Because we went L, we want W. So let's change that L to a W. And that'll be cleaner. And you can see we've got penetration, we're in the right direction, and we're going through both things. Alright, so let's take that highlighting off, and you can see now that when we print this out, we're going to print out with a hole through the end of it. There it is. And that's basically where we want our hinge to go. I'm going to have to drill mine out because I didn't leave that hole in it. But there you go, that's how you put a hole in something. Righto, so we're going to wrap this up. We're going to do some 3D printing. I'm not going to take you through that process. People have seen me use Repeatia Host before to get things to work. I'm going to save this. I'm going to compile it. Nice quick compile, STL file. Oh, that was just the, hang on. I screwed up. Sorry. That was too quick. We didn't print the box. I'll leave that there. I'll comment it out. If you just want to print the lid, just print the lid. Save it. Print it out. Right, so there's our box. There's our lid. You can see we've got an overhang. That's going to come. That's beautiful. That's going to be perfect. So we're going to have a gap at the top and blah, 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 and it's all good. And life's ball with Jaffers, you know. So we got our hinge. We got a clasp there on the front. You can see there's a little bibby bobby thing there. Just hold it proud. It works fine. I haven't put one inside the lid. I didn't need to. I didn't put a handle on it. If you want to chuck a handle on things, you can chuck a handle on it. Life's good. Life's good. And yep. I'm in a good place. Save it. Let's render that out. It should take a few minutes because we're using linear extrude. Now we could have used a couple of cylinders and a couple of cubes, right? Instead of linear extrude and got the same result, and it would render out a bit quicker. But it's much more fun playing with like the advanced bits of code. You could use 2 cylinders and 2 cubes. You can see that, and you can hollow that out in the same way as you did with your box. and it would do exactly the same thing. You just got to position it correctly inside your box to get your correct thickness. And we've already shown you how to do that. There we go, we're rendered. Let's build the STL. Thank you so much. Save that. Yes, thank you. And what I'll do is I'll zip this project up and put it up to the Git repository. So you will be able to get it with the STL. I'm just going to open the other software, the Repetia software. I am not going to go through the printing process again. I'm not going to print a second one of these. Now it takes about 1¼ meters of cord of your. So if you haven't got 1¼ meters left in your spool, you're going to run out. Mine probably took a bit more than that actually. It probably took nearly 2 meters by the time I finished, but then I've got it on a fairly high quality print. Here's Repetia coming at you. We'll load up the design so you can see it. Project box with lid. And you can see it fits in my printer. There it is. So there's my printer. There's my lid. My box in the printer. This is the full size of my printer. For some reason the software only recognises the grey bit. So I had problems with that, but I positioned it and I printed it and I ended up printing it out. So you can slice this. I just used the default slicer in this instance. It only takes a few minutes to slice it up. And when it finishes, hello, finish. There it is. Talk to me. There it is, rendered as a sliced up, ready to print out. And that took close to 5 hours to print out for me. Right, so that was a 5-hour print. Now it says it wants, 3.5 meters. Well, 35 meters actually. It doesn't take that. It's nothing like that. This software doesn't do that very well. I think it takes about 2 meters of cable off the spool. They're millimeters, so it's saying it's taking 35 meters. It doesn't take anything like that. It's out by a factor of 10 at least. So the most it will take is 3.5. It didn't do that. It only took about 2 meters at the max, probably even less. All right, and that 7 hours is wrong. It took about 5. You can do things like reduce the infill. You could make it thinner. So if you only wanted a 1 mil chassis, like a 1 mil thickness, you'd reduce this print time and this filament needed quite substantially. You could make it 1 millimeter thick, and you'd still get a fairly decent project box. Mine's 2 mil thick and I'm happy with it, and I'm going to leave it exactly like it is because it's quite robust and it's going to store my bibs and bobs for years to come. Righto, so let's just come out of this. Now this is Repetia software. In here they have got their repetia.com things, and as you can see they too give you a GNU end user license agreement. That's the standard boilerplate stuff. They do have a donate button in there. I donated to them. It is my intention to buy this software at some point when I've got a bit more finance. I get a bit more financial. So there you go. I'll zip those files up. Let me just swap cameras. Swapping cameras. There you go. I'm going to zip those files up and put them in the Git repository, which you'll find down in the comments. Talking of comments, please leave your comments below. When I said comments, of course, I meant the description. But down in the description, you'll find the Git repository for downloading those files. I'll like you to support the openscad.org. Give them a bit of a donation. By all means, support me. My website is nightglowmanufacturing.com. You can buy my little NGEMs, which if you don't know what they are, these are my NGEMs. I've got one up over here. And if you cover the lens, see how it glows? They glow in the dark. And you should be able to see that little red light coming on. And if I take my hand away, it gets light and stays light. They're basically a little emergency marker for when the lights go out at night. If all the lights are out, they'll be glowing even when all the power's off and all the lights are out. And why I built it, I had a mate with an elderly grandmother, and for whatever reason, old people, when they wake up at night, they don't turn the lights on. They can't see where they're going. They forget where the stairs are, and she took a horrible tumble down the stairs and broke her hip. And, you know, it was pretty traumatic for her and the family. And I come up with this idea of having these little marker lights that they could put along the rail so that she could see where, like, she still doesn't turn the light on. She goes to the loo. She doesn't want to disturb people, and so she doesn't turn lights on. And of course, now they've got a gate across the top of the stairs to stop it falling down. But you know, they've also got these little marker lights there. I gave them a box. I employ disabled people to make them. Okay, so I give disabled people jobs. I'm not producing at the moment. We're shut down because of COVID. But when we get rolling again, we will once again be taking orders. I can't get supply. That's the problem. And we make those out of recycled materials. So they've got recycled. The plastic I'm using here is all recycled, and I recycle it as well. So if, I've got a little machine that I'm building up to chop all the plastic up and melt it back into strands, so I can put it back through my printers. And I 3D print those out. You know, and the kids, they come in, they're disabled. I pay them a full wage, you know, minimum wage, but I pay them. And they get a job, and you know, they feel like they're contributing, and they are. And hopefully, I can train them things like a bit of programming and a little bit of this and that. And if I can train them enough, I can get them a job somewhere else, and they move on and they get a job, and they're contributing. You know, they're disabled, and they're contributing to the community. And they're feeding themselves as well as paying for their carers and whatnot, because they've got to have their carer and they've got to have. But I give them and some of them work from home. We use recycled wrapping paper, so we make our own wrapping paper. We recycle it, and I get them to paint on the. They can paint, you know, and they paint a picture on the wrapper. So when you unwrap your bizzo, you've got a little painting that's done by some disabled person, you know, and they come up with some of the most brilliant things to paint. And a lot of people put them up on the fridge and whatnot, and don't throw them out, and they use them, you know, and they'll reuse the paper and wrap something else and send it off. And I think that's brilliant. That just encourages people to recycle. And of course, you can recycle the wrapping paper. At the end of the life of the NGEM, I encourage you to send it back to me, and I'll completely recycle it. So I haven't had any come back yet. They last a bloody long time, so I haven't had any come back. But they can be 100% recycled. I will reuse all of the components, the batteries, everything. I'll recycle it all. The batteries get recycled. Everything gets recycled. I buy recycled batteries. So like they come out of old computers and things. The CR2032s. And they go for a fair old time before they give out. And you can replace the battery. You can pull it apart, replace the CR2032, put it back together, and it'll go again, you know. So they'll go for a long, long time. Anyway, I think whatever you do, I want you to make good decisions and do good things. If you think you're doing it tough, you know, I'm doing it tough. some of you might know my story. I've had to pick myself up a few times. I've had health issues. I've had business issues. I've had a few things go on, and I'm still swinging. So I want to encourage you to keep swinging. Go after whatever it is that's worthwhile. Make a good decision. Do a good thing. Be good to each other. Keep swinging at your goals. And I'll see you guys at the next video. And don't forget nightglowmanufacturing.com, openscad.org, and Repetia, whatever it was, Repetia host.